Hello. So we are going to present our final year project on agentic AI for autonomous task execution. So starting with the introduction, artificial intelligence has been around us for a long time, and there has been a lot of advancements in the field. And we have recently there has been the involvement of ChatGPT in our lives, and we have been using it for a long time. But ChatGPT is very limited to conversation. They can answer our queries and suggest us some actions to do some tasks, but they cannot actually do those tasks. So our project is focused on bridging that gap and making AI even stronger. So coming to the research gaps, current AI assistants such as ChatGPT are limited in the direction of execution capabilities, so they cannot execute real-time instructions and tasks that need to be executed. Another research gap is that even if we were to integrate a tool into the system, it will be only able to use a single tool and not multiple tools. So our focus is on integrating multiple tools such as web search and automation and create a unified agent. And another research gap is that there is no real-time interaction with the dynamic web content. So nowadays GPT has got the feature of getting information from the web, but it cannot interact with the web itself like a normal human does. So these are the research gaps. So depending on these gaps, we have defined our problems such as we want to create an AI assistant which has all the capabilities that one wants from an AI assistant, such as getting information from the web, controlling the web like a normal human does, browsing it, surfing it, and communicating with the user. So using focusing on these three main capabilities, one of information retrieval, one of web searching, and one for communication, we are creating an AI agent with three capabilities. So our objective is to design and implement an AI agent capable of invoking external tools. So like I mentioned, email for communication, search for information retrieval, and browser control for surfing the web. And use these tools to like answer the user's query. And once the system is built, we want to evaluate its performance using task completion rate and natural language inference score, and so that we can compare it to existing GPT models on the web. So we can compare it and look at the effectiveness of our system. So coming to the dataset part, Sagar will continue on that.
Right. So here we created a custom benchmark dataset of 40 queries, which was basically representing what our task would look like. The queries were divided into 4 categories, namely email automation, web search, browser control, and the combination of all these 3 tools. For each query, we also generated a reference summary, which was written to represent the ideal execution steps which our system should be taking. And the same query was executed by both the proposed agent and our chatbot, which in our case is GPT 3.5 Turbo. We then stored these in the dataset and compared to the reference summaries using NLI scoring. So these are the attributes which will be in a data set: the query, which will be the task which it's supposed to execute, the category in which it belongs, the reference summary which we had generated, the responses which we received from our baseline chatbot, the execution status, which is basically if it is success or a failure, and the analyze score, which is the semantic similarity score. So this is what our data set looks like. As you can see on the left, an example query would be sending an email to a particular recipient, and we put this query in both the proposed agent as well as our baseline chatbot and stored the responses.
So now coming to the proposed design, this is how our overall architecture would look like. So this is our main AI agent where a user would send a query to the AI agent. Once a query is received by the agent, it will start an agent executor chain. And this is the GPT model, which is the main thinking entity of the agent. And the GPT model is combined with instruction and context-aware prompt. And beyond these prompts, it has also been given the capabilities in the tool library, which actually makes it as an agent. So in the tool library, we have one tool for sending an email, one tool for searching the web, and one tool for controlling the browser, just like a human does. So building on these three tools, a tool library is created, which is combined with the GPT LLM, which actually creates the agent. So once a query is sent, the agent executor cycle begins, and the GPT model it understands the query along with the prompt, and it decides a certain in a structured plan how to execute that query, and based on that, it will decide which tools to be selected. And from the available tools in its library, it will select one of the tool and decide its parameter and execute that tool. So once the tool is executed, the response is generated and it is sent back to the LLM. And if it still needs to execute more tools, it will go back in the loop and execute those tools. Once all the results needed are fetched and sent back to the LLM, it will have all the responses that it needs from the tools. And based on that, it will generate a final response to be sent to the user. And the agent executor chain will end and the user will receive the final response. So this is our proposed design, like just like I explained the input, the AI agent combining the LLM plus the tools, which is we are using GPT 3.5 as an LLM. I think, yeah, 3.5 Turbo, because it is also on the opposite side in the comparison for the baseline chatbot. And these are the three tools that we have created. One is for email, one is for web search, and one is for browser control. And yeah, that's it on the architecture side. Coming to the evaluation criteria, Sagar will continue on that.
So moving on to the evaluation criteria, to assess how good our proposed agentic system performs, we basically come up with 2 metrics. One is task completion rate and another is natural language inference, which is the NLI score. So task completion rate is a binary metric, which basically represents if a task has been successfully executed or not. So the values will be just 1 and 0. And the NLI score is a common NLP metric, which is used to evaluate how similar two texts are. So in this case, we'll be evaluating how similar our system's response will be to the baseline reference which we had generated. So going forward to hypothesis testing, our first hypothesis test is basically to see if our agentic system is able to complete all the tasks. So the null hypothesis will be that the system's task completion rate is less than equal to the chatbot's task completion rate, which is TCR of a tool is less than equal to TCR of a chat. And the alternate hypothesis would be that our system's task completion rate is greater than that of the chatbot. So hypothesis two, so the results are, as you can see, our system performs at a metric of 82.5%, while our baseline chatbot, the GPT 3.5 Turbo, performs at 32.5%, which proves that our system is more capable in terms of task completion rate than our baseline. So our hypothesis two will revolve around the NLI score. The null hypothesis will be that the NLI of our tool is less than equal to the NLI of our chatbot. And the alternate hypothesis would be that our system's NLI score will be greater than that of the chatbot. So according to the result table, we found that the NLI score of 3.5 had an average value of 0.38, while our proposed agent had a value of 0.81. Thus rejecting the null hypothesis and proving that our system performs better in both the TCR as well as the NLI score. So the final result analysis says that the agentic workflow system outperforms the chatbot across all categories in both task execution and response accuracy, as I already said. Overall TCR being 82.5% over that of the chatbot being 32.5% shows that our system performs better in real world task execution. Our NLI score of 0.81 over that of 0.38 of the chatbot shows that our system is better aligned with the expected task logic. And both the hypotheses were validated and confirming that our system is overall a better framework than that of the baseline chatbot.
So now coming to the implementation, I'll just switch to the code editor, and I'll show you how the system. I'll just show you a quick demo. So over here, I have the query to send to my agent, and I'll get the response in my terminal. So I have a sample query ready where I am asking to do a web search for the current India-Pakistan war news and email it to me on the following credentials with the subject and the news in the body and the credentials of the sender and the recipient mentioned. So when I run this file, so like I had explained in the architecture, a new agent executor chain begins, and these are the parameters that it had decided. This is the tool that it has decided to use, and this is the parameter of the tool it has decided to use. And these are the search results that it got from the web using the web search tool. And since it is a multi-tool query, it is now invoking the send email tool with the following parameters, like email address, subject, the contents of the email, and the sender and recipient. And this is the output, like email sent successfully. And for just for comparison purposes, we have instructed the model to like the agentic system to give us a summary of the steps it took to execute the task at the end. So this is the summary that it has given me. And this is what we are using to compare with baseline chatbots in terms of analyze code. And here it shows that the chain has finished and the email must have been sent. So I'll just go to my Gmail. And this is the email that it sent me with the proper links, proper header, like I mentioned, subject, like I mentioned. And thus showing that this is something that baseline chatbots cannot do, proper real-time instruction executions, and our agentic system is able to perform that. So yeah, that's it. I have a few other screenshots of implementation, and yeah, that's it from our side. Thank you.
Thank you.